Hi, today we'll be talking about AP Chemistry Unit 4.2 Net Ionic Equations. Alright, so what is a net ionic equation? So a net ionic equation is basically a chemical equation that only shows the ions or molecules that are directly involved in the reaction, and it excludes any spectator ions, but we will get into what spectator ions are later. Okay, so to understand net ionic equations, you have to understand basic chemical equations. You need to know that chemical equations actually represent the chemical changes, and the representation of a chemical change has to be concrete. It has to have an equal number of atoms on each side. It is non-negotiable. If the equation is not balanced, it's not valid. So hopefully you understand the basis of chemical equations. Now we can move on to starting net ionic equations. So the first thing to do when starting a problem is to determine what your products are going to be. And you can simply determine what the products are going to be just by determining first what kind of reaction is it. So if you are given KCl plus PbNO3, which is potassium chloride plus lead nitrate, you know that that is going to be a double replacement reaction simply based off there are two compounds given, and you know that you're going to have to switch the charges, and you should be able to know what to do. And also, when making your products, do not forget about the diatomic elements, which are listed below. Okay, so after you have your products, the next thing is to write out the phases of the ions in the equation, or the molecules. So for this step, you actually need to know your solubility rules. It is best to memorize them by heart, but if not, you can always have a reference sheet available. Okay, so far we have our product and we have the phases on them. The next step would be to balance the equation. Now this step is crucial. You have to balance the equation. So the steps to balancing equations are very easy. First, you should write out the equation. Then you should count the atoms on each side to compare. If you're new to balancing equations, you could make a table like shown in the picture. I think it's much easier if you're starting out. Then you must think, what number can I change the coefficient to make the elements the same on both sides? Then you can just recount the atoms and make sure everything's good. Now we can make our total ionic equation. So to do this, we have to identify all the aqueous substances in our reaction and dissociate the compound to make a new equation. So this equation is essentially the singular ions plus the compounds that are non-aqueous. Okay, now we need to cancel out our spectator ions, which are simply ions that do not undergo chemical reactions. They appear the exact same on the reactant and product side and need to be canceled out to make our net ionic equation. Alright, so once you have canceled out all the spectator ions, whatever is left from canceling them out is going to be used to make our net ionic equation. So that's all, and now we will do an example problem. Alright, so let's start. Here I have lead nitrate mixing with potassium chloride. So what is the first step with this problem? We have to make our products. So we can see that lead has a +2 charge because of this. So now we have to see what charge on the other side also has a negative charge. So we see that chlorine does. So we can write out chlorine and we can do our crossing, and we discover that it's going to be, one of the compounds is going to be PbCl2. Now the next we have to do whatever's left essentially, but also they have negative charges and a positive charge. So NO3 is negative, potassium is positive, and we don't really need to cross them out, and we know that one of the compounds is going to be KNO3. Okay, so we have both our compounds, KNO3, and PbCl2, or just potassium nitrate and lead chloride. Alright, so now what is our next step? Of course, to determine the phases. So if you know your solubility rules, we know that nitrates are aqueous. They're always soluble. And you should know solubility rules, and you should know that chlorine cannot be soluble with lead. So PbCl2 is actually a solid. Alright, so we've got our phases. The next step, of course, is to balance this equation. So I like to start with whatever I see that's in parentheses. So NO3 is in parentheses. So we see that it has 2. There are 2 NO3s, which means we need to add a 2 on the product side, right? But now we have 2 potassiums here. So what we need to do is we need to add a 2 on the other side with potassium. And I believe that's it, but of course we can always recount. You should recount actually. So PB 1, NO3 has 2, NO3 has 2, potassium has 2, potassium has 2, and chlorine has 2, and chlorine has 2. So now our equation is fully balanced. Alright, so now that we have our equation fully balanced, the next step would be to write our total ionic equation. So to do this, remember, we must dissociate all the aqueous compounds. So we can write Pb, aqueous or lead, just as the ion, NO3, aqueous of course, 2NO3, aqueous as the ions. Do not forget the charges. 2K, aqueous or potassium, plus 2 chlorine, aqueous, and then the arrow of course. Now we write 2 potassium again, aqueous, plus 2 NO3 aqueous. And since lead chloride is a solid, we do not dissociate, we do not separate it. We leave it as is. Alright, so our total ionic equation is finished. The next step would be to cancel the spectator ions. So 2NO3 and 2NO3 is the same on both sides. 2K and 2K is the same on both sides, which means they are spectator ions and they needed to be canceled out. So Pb is left, 2Cl is left, and PbCl2 is left. So these will be made into our net ionic equation. So we write it out as lead, aqueous lead, with the charges of course, plus 2Cl aqueous, and the arrow of course goes to lead chloride solid. And this is a precipitate reaction because aqueous plus aqueous is resulting in a solid. So now it's complete. This is the net ionic equation, and now you know how to write net ionic equations.